Okay, this video is going to cover what a function is, and really what we're going to focus on is two things. First, what are they? And then what do they look like? So, and this is a good place to take notes. To help us understand functions, it is necessary to know what a relation is. So first we're going to talk briefly about that. So a relation is just any relationship between two variables. So you could talk about any of these. For each of them, you're going to have an input and you're going to have an output. So you could say input somebody's age, and the output could be how many hours they sleep. Or input how much time is spent, and then the output is how much pay you get. You could input a shoe size and output a height. All of these are relations. Some of these are functions. So a function is a relation with at most one output, a y value, for every input, an x value. So we go over here, there's probably a lot of, I'm 35, there's probably a lot of 35-year-olds, and we probably don't all sleep with the same amount. I gotta get 8 hours of sleep. I'm pretty worthless without it. But I might input 35, output 8, but I bet there's other 35-year-olds that only get 6 hours of sleep. So input and different output. Whereas if you have a job, hopefully the amount of time you work correlates to the amount of pay you get if you're getting paid by the hour. So like 8 hours, $90. 10 hours, $150. 1 hour, $15. Whatever it is that you're getting paid, hopefully there's a relationship there. And then you can say, okay, if your shoe size is 8, how tall are you? That's a relation. That's not necessarily a function. Okay. So again, function, one output for every input. Okay, so let's look at a couple different kinds of functions. Here we're going to look at functions as a graph, as a table, a mapping, and an equation. And in each case, you'll notice there's a green and a pink version. And in each case, the green is a function and the pink is not a function. So let's look at a graph. So over here, there's a couple different ways that you might picture this. I'm going to give you some examples, and then maybe we'll start thinking about it together. So here is an example of a function. That right there would be a function. This right here, not a function. Okay, let's do that again. So I'm going to get rid of these two and let's say, okay, here's another example of a function. That one, totally a function. This one, totally not a function. It's a little confusing, right? So let's make sure that we understand why each of these is a function or not a function. I'm going to just draw a pretty simple one for us over here, kind of like part of a parabola. And this one I'm going to draw a circle. Okay. One of the ways that you can tell if something is a function is by something we call the vertical line test. If you remember, this axis and both of these is my x-axis and my y-axis. And what we said is that for every x, there can only be one y. So if I come over here and I'm like, okay, at this x value, what's the y? So I come over here, I look down here, I'm like, oh, it's about there. That's the y value. So maybe this is 1 and this is a -2. So that is a point on my function. Over here, if I go over to 1 and I'm like, okay, here's 1, then I need to find my y value. And I can go up here and it's like, well, maybe that's a 2. That function, but the problem is that it also has a partner down here, maybe at -2. So this one has two different outputs and it's not a function. One of the ways you can tell that this is true is you can use the vertical line test. So let's get ourselves a vertical line. Here's my vertical line. Using the vertical line test, here's what we do. Starting on the left side of the graph, move your line all the way across the graph. And if your line only touches the function at one single point, so like right here, that's where it's touching the function. If I move it back here, now it's only touching the function right there. If it only touches one time, then it's a function. So here's our rule. If the vertical line only touches one time, then it is a function. So let's try that over here. Maybe right here, it's working. Maybe it's only touching one time. But as soon as I start moving this over, then boom, all of a sudden it's touching once, twice, and it's no longer acting as a function. So this one is not a function because it's touching at more than one place. Just like over here, when we get it lined up with 1, and I make it actually look a little bit more vertical, my bad, then now you'll notice here we've got it's touching here and it's touching here, so it's touching at 2 different places. That makes it not a function. Same thing we can see in a table. So in a table, the idea is if you ask for an input, it'll give you an output. Maybe the output here, and it doesn't really matter, but maybe the output here is 5. And then if the input is 1, the output is 6. If the input is 2, the output is 7. If the input is 3, the output is 8. And now I'm going to ask it for 3 again. If it's a function, it already told me when I input 3, I should get out 8. I darn well better get out 8. This, check, is a function. Now let's say the same thing happens over here, but I go 5, 6, 7, 8, 9. Then, warning. What's happened is I input 3 and it said 8, and then I input 3 again, and this time it said 9. So you can't trust this thing. It's got 2 different answers when you ask it for 3. So this is not a function. Okay, moving on to a mapping. Now you may have not seen mappings before. They're fairly simple, but they're just not as common. The idea is that maybe this is a game, and if you roll a 1, then you get some number of points. So I'm going to say I roll a 1, I get 13 points. I roll a 2, I get 10 points. I roll a 3, I get 12. I roll a 4, I get 8 points. I roll a 5, I get -1 points. This works because every input has only one output. Notice from each of these, there's only one arrow coming off of it. If it was not a function, maybe when I input 6, sometimes I got 12 and sometimes I get 10. And it doesn't matter if the rest of them are following as a function, right? 0 only gives me one answer. 4 only gives me one answer. Because 6 could give me 2 different answers, that makes it not a function. And the last one, this is an equation. This first one, let's try, and we're going to make a table to go along with our equation because I think that might help us. So if we try and we put in k and we input 1, so we're going to plug in 1 and find out what we get. We'd have 13 minus 1 squared, and that's equal to 12. So my output is 12. Now let's not have 1 be our input, but let's try inputting 2. Okay, our output is no longer going to be 12. In this case, we're going to have 13 minus 4, so our output here is going to be 9. So input 2, output 9. If we input 3, you can figure this out for yourself, but my output would be 4. And there's nothing that I can do where I'm going to input something here. I can't input 3 and get a different answer. It's going to always work this way. That doesn't happen down here. Let me show you. If we just start by inputting 1, x, and over here we'll get y. FYI, we haven't talked about this, but k of x and y are basically the same thing. Let's input 1. So I'm going to say 10 is equal, it's the same thing as 1 squared plus y squared. Well, that's like 10 is equal to 1 plus some number. And that some number has to be y squared. Well, that has to be 9, so I can say, cool, y squared is equal to 9. Well, 3 works, right? Because 3 squared is 9, but here's the tricky bit. -3 also works. Because -3 squared is -3 times -3. 2 negatives multiplied gets us a positive. 3 times 3 is 9, so I could also input 1 and I'd kick out -3. Because of this, sometimes you input 1 and you get 3. Sometimes you input 1 and you get -3. This is not a function. So we have a whole bunch of different examples. Make sure you do your homework tonight, which was a Desmos activity, and you're going to be sorting like function, not function, function, not function, function, not function. Let me know what questions you have.